Hi students. So today, as a part of the Polymers unit, I am going to discuss the very important topic, which is the driving force in order to understand the further topics in the polymeric unit. Now that driving force in order to understand the further polymeric unit is the types of polymerization. Types of polymerization. And if you understand the types of polymerization only, you can understand the further units which are a part of the polymeric unit. Otherwise, it becomes a nightmare for you to understand the other topics which are a part of the remaining polymeric unit. So, types of polymerization. So, we can say that it is a driving force, right? So, now, from the previous class, it is amply clear that the process which involves a repeated combination of so many smaller structural units resulting in the formation of a large molecule, which is so called as polymer, is called as polymerization. Now, this repeated combination of the monomeric units into a polymer can take place by three ways. That is, the monomers can be converted into the polymers, making use of three polymerization reactions. The one is addition or chain growth polymerization. The second one is condensation or step growth polymerization. And third one is copolymerization. These polymerizations are the types of polymerization which converts the monomeric unit into a polymer, into a wide variety of polymers. So first and foremost, let us discuss what is addition or chain growth polymerization. Addition or chain growth polymerization. So first of all, I would like to give one phrase for you. And this particular phrase is quite common for the definition of all the polymerizations, that is three polymerizations. The phrase is, this polymerization involves the repeated combination of. This particular phrase is quite common for the definition of all the polymerization reactions. Keep this in the mind. So accordingly, addition or chain growth polymerization. Let's see what is addition or chain growth polymerization. This polymerization involves the repeated combination of unsaturated monomeric units, resulting in the formation of a polymer whose molecular weight is an integral multiple of the original monomeric units participating during the polymerization. This polymerization involves the repeated combination of unsaturated monomeric units resulting in the formation of the polymer whose molecular weight is an exact integral multiple of the monomeric units participating during the polymerization. What do you mean by this exact integral multiple of the monomeric units participated during the polymerization? I will discuss that. But based upon the definition of addition or chain growth polymerization, it is very clear that unsaturated molecules undergo addition or chain growth polymerization. Now the question is, which type or which class of organic molecule comes under the category of unsaturated monomeric units? So we have two class of organic molecules which comes under the category of unsaturated monomeric units. The one is alkenes and alkynes. Accordingly, the monomeric units which do undergo addition or chain growth polymerization are alkenes and alkynes. And do remember, students, during the addition or chain growth polymerization, either linear or branched chain polymers are going to be produced. And in the first video which I have made on the polymers, I have explained that among the linear branched and cross-linked polymers are strong due to the presence of cross linkages between the adjacent monomeric chains by which they are rigid in nature, right? So now, when we are saying that the cross-linked polymers are strong or rigid in nature, definitely we can say that the linear or branched polymers are weak. Now, this addition or chain growth polymerization is going to produce either the linear or branched polymers. Accordingly, we can say that this addition or chain growth polymerization produces weak polymers. And the next important point which is to be noted during this addition or chain growth polymerization is, during the addition or chain growth polymerization, none of the molecule is going to be lost. That is, none of the molecule is going to be eliminated. There is no loss of any of the molecule takes place during the addition or chain growth polymerization. The next important point related to addition or chain growth polymerization is, the addition or chain growth polymerization results in the formation of thermoplastics. And what are thermoplastics? I have clearly explained in the previous video which I have made on terms involved in polymers and classification of polymers. Right. Now, what are the examples of the thermoplastics? Polythene, polyvinyl chloride, polystyrene, polytetrafluoroethylene. Now, these are the examples of the thermoplastics. Since these are the examples of the thermoplastic, and as these thermoplastics are being made by addition or chain growth polymerization, we can say that these polythene, polyvinyl chloride, polystyrene, polytetrafluoroethylene comes under the category of the polymers which are made by addition or chain growth polymerization. For example, I will take the preparation of polythene. For the preparation of polythene, what is the monomer, students? Ethene is the monomer. This at 100 to 200 degrees centigrade temperature and 100 to 250 atmospheric pressure, in presence of benzoyl peroxide. What is the role of benzoyl peroxide? I will discuss in the next video. But do remember that ethene, whenever the temperature is being maintained at 100 to 200 degrees centigrade and the pressure is being maintained at 100 to 250 atmosphere, and in presence of benzoyl peroxide, ethene converts to polythene. And already I have said that whatever the number or alphabet which is there before the monomeric unit becomes subscript in the polymer, and whatever the double bond which is there in the monomer becomes a single bond in the polymer. And whatever the double bond which is present in the plane, do remember this, whatever the double bond which is present in the plane will convert into the single bond, and whatever the single bond present in the plane will convert into the double bond. So we'll come to know exactly why the double bond is getting converted to the single bond and single bond is getting converted into the double bond during the copolymerization. So in this, what happens? So CH2 remains same. Now the double bond, it is in the plane, so it converts to single bond and CH2, and whatever the number or alphabet which is there before the monomeric unit becomes subscript for the polymer, which is polythene, which is polythene. Right. Now, dear students, I'm going to discuss what is the meaning of the polymer which is being resulted, whose molecular weight is exactly integral multiple of the monomeric units participating during the polymerization. What do you mean by that? That is, for example, let us say that 50 ethene molecules are undergoing polymerization, results in the formation of CH2 taken 50. So based upon this, we can say that whatever the molecular weight which is associated with the resulted polythene is same as the 50 ethene molecules. Let us say that 100 ethene molecules are undergoing addition or chain growth polymerization, results in the formation of CH2 taken 100. Now the molecular weight of polythene which is formed is exactly equal to the number of ethene molecules, that is 100 ethene molecules. 100 ethene molecules. That is the meaning of the exactly integral multiple of the monomeric units participating during the polymerization, which is there a part of the definition, right? So for example, let us take 2 moles of ethene. 2 moles of ethene, right, undergoes addition or chain growth polymerization under same conditions. So now what happens, students? Whatever the number which is there before the unsaturated monomer unit becomes subscript, and the double bond converts to single bond. So double bond converts to single bond. So CH2, and the number which is there before the ethene is 2. It becomes subscript in this case. Now, what is the meaning of it? So how many carbons are there, students? 1, 2 carbons are there. So 2 into 2, 4. 2 into 2, 4. So how many hydrogens is there? 2 plus 2, 4 hydrogens. 4 into 2, 8. Now this is the molecular weight of the polymer which is being resulted by the combination of the 2 moles of ethene, which is the monomer. Now what is the molecular weight of this? So 2 carbons, 2 into 2, 4. So how many hydrogens are there for this carbon? 2 hydrogens. And for this carbon, 2 hydrogens. So 2 plus 2, 4. 4 into 2, 8. This is the meaning, students. That is, during the addition or chain growth polymerization, the polymer which is going to be produced, its molecular weight is exactly equal to the molecular weight of the monomeric units participating during the polymerization. Right. So now, what is the role of benzoyl peroxide, and how this ethene is being converted into polythene in the presence of benzoyl peroxide? I will discuss in the next video. But before that, I would like to throw some light here. That now, by seeing the reactions, students, can you tell me what is the exact role of the reactant, which is ethene? Reactant means the starting material, which is ethene. And what is the exact role of the benzoyl peroxide here, which is a reagent? So by seeing the reaction, we cannot predict the role of the reactant or the reagent, which is a part of the chemical reaction. So in order to understand the role of each and every reactant, because this particular example contains one reactant and one reagent, it doesn't mean that all the chemical reaction contains only one reactant and one reagent. Right? One reactant and one reagent. Right? Now, in order to know, in order to find, in order to predict the role of each and every reactant and reagent which is a part of the chemical reaction, we need to study the mechanism of the reaction. We need to study the mechanism of the reaction. When we study the mechanism of the reaction, then only we will get the idea about how the reactant, which is the starting material, in presence of reagent, is converting to the product which is the ending material. That is the mechanism. The mechanism gives the information. It gives the information means it is the one which predicts the role of each and every reactant, each and every reagent which is a part of the chemical reaction. Accordingly, the definition of the mechanism is as follows. It is a systematic representation of the overall reaction by which we can know the role of each and every reactant and reagent which is a part of chemical reaction. Now, what is the mechanism involved in the addition or chain growth polymerization? That is, what is the role of the reactant ethene? What is the role of benzoyl peroxide, which is the reagent? And how the benzoyl peroxide is converting the reactant ethene to polyethylene. Everything becomes crystal clear if you write the mechanism of it. So in the next video, I'm going to discuss that only, the mechanism involved in addition or chain growth polymerization. It is not that easy topic, student. It is the complicated one, but I'm damn sure that I will make a piece of cake for you. Mechanism, I will make it as a piece of cake for you. No doubt in stating that. So thanks for watching this video. So be ready to watch the mechanism involved in addition or chain growth polymerization. That will be my next video. So please do comment on the video. So thank you for watching this.